So this video is going to be on the atmosphere, the layered parts of the atmosphere, and how the properties of the atmosphere change as you move through the atmosphere. But part of this is also going to be on energy transfer in the Earth and where there's energy comes from. And we've talked about energy transfer a little bit, but the first thing that I want you to look at is where our energy comes from. And one place is inside the Earth. It either comes from the heat that was left over from when the Earth was formed, because the Earth was just this big molten blob when the Earth was first forming 4.5 billion years ago, and then it slowly cooled over time, and some of that heat is left over. It's also from radioactive decay. And if you remember elements like uranium 238 and rubidium and carbon 14, those radioactive elements, when they decay to their daughter products, like we learned last unit, they give off some energy. And some of that energy is heat. And so that helps to keep the Earth's temperature warmer than it would normally be if without them. That's a small amount of our energy that is inside the Earth, that's that we have. Most of our energy is coming from something else, though, coming from the sun. Incoming solar radiation, insolation, is the term that we use to describe sunlight. And so you'll see that a lot. We'll talk about insolation and angles of insolation, and you'll see this term quite a bit. So get used to basically thinking that the insolation is sunlight. They're just synonymous with one another. They're one and the same. Now, if you turn to page 14 in the reference table, you'll see that there's a chart here at the top of the page 14, and it has three different things: temperature, it has pressure, and it has the concentration of water vapor. And the amount of the water vapor in the atmosphere as you move in from the sea level all the way up. Okay, Josh, pay attention. Kyle, stop turning around looking at Katara. Oh, and put your phone away. Okay, I thought you needed a little something to break that up. Anyway, if you look at the altitude, here's your altitude at sea level. As it's going up, you can see what happens to these changes in the atmosphere. In the troposphere, as you go in, this is the first layer of the atmosphere, the troposphere. There's a break here called the tropopause, and then you have the stratosphere. The stratosphere then turns into the mesosphere and then the thermosphere. We have those four layers of the atmosphere, and those layers are very distinct for lots of different reasons. And one of the things that you'll see is that in the atmosphere, oops, sorry about that. In the atmosphere, sorry again, I'm freaking out here. What's going on? Okay. In the atmosphere, you'll have most of the water vapor is found in the troposphere. You'll see it down here. Here's the troposphere. The water concentration as you go up goes down, so you get less and less water as you go up. The atmospheric pressure as we go up starts off at 1.0, and it goes as you move up in the atmosphere, as you go up into the stratosphere. What happens to that? It goes down, right? Decreases. Most of the weather happens in the troposphere. Why? Well, if you look, that's where all the water is. And weather is all about water. It's whether you're getting rain, and that water has lots of properties that help to transfer energy throughout the atmosphere, but primarily it has to do with clouds and rain. And so most of the weather happens down there. Now, as we move into the temperature scales, and I want you to see this, here's your temperature in degrees Celsius. At sea level, if we were standing, we would be right here. We'd be right down at 0 degrees, or not 0 degrees, at 0 miles or kilometers above sea level. As you go in the troposphere, from the sea level up to the top of the troposphere, the temperature goes from 15 degrees all the way down to -55. And I think we've looked at this a little bit already, but it bears repeating. The As you get into the stratosphere, though, something strange happens here. There's this weird thing where the temperature actually goes up, and that temperature goes up for a really good reason, and that's because we have ozone in that layer. So this is where, right here, is where the ozone layer is, and ozone is just O3. So ozone is O3, and that's right here is where the primary area for the ozone layer is, right in there. And because of that, you get wavelengths of UV light. So UV, ultraviolet light, comes in. It's absorbed by this ozone layer, and when it absorbs it, it takes all that energy and warms up the molecules. The molecules start moving faster, just like we talked about a little while ago. And as that energy creates molecular motion, makes those molecules move faster, the temperature goes up, and so we see the temperature increase in the stratosphere. Mesosphere, temperature goes back down, as you can see there, so it's decreasing again. And in the thermosphere, does this strange thing where it goes up and it gets really hot, but you're out in basically suborbital outer space. This is where the International Space Station travels. That's where the space shuttle flies. So you can see that temperature goes up there, but the problem is there's not really any atmosphere up there. There's very little pressure. There's very few molecules up there to transmit any energy. So there's not much to be said in terms of the energy out there. So in reality, if you were out here in space, it would be cold. But if you look at it theoretically, the temperature should be high. So it's kind of this weird contradiction. Don't worry too much about that. Now, the last thing, and this is the last bit on here, is on page 1. You've seen this chart before. It's on the bottom of the first page of the reference table, and I just want you to write down the percent by volume in the troposphere. So what are the percent by volumes of each of these three elements? And we can see that one of them is a much larger component of the atmosphere than the others. But and this oxygen came from living things. A long time ago, plants and other organisms were producing lots of extra oxygen, and that's where we got the oxygen that's in the atmosphere today. So what I'd like you to do next is fill in the question summary, the summary of what the notes were about, and come up with a question that either you have still, or a question that this rose for you, or a question that somebody might have after watching this, or a connection that you have to your life or something that you've seen before. So I'd like you to think about that and fill in that form. Go back to mrgelder.blogspot and connect to that form and fill in the summary. Thanks.